We propose a generative approach to model future human behavior in 3D based on 2D observations without paired 3D data. We focus on complex long-term behavior with multiple steps. To tackle this, we jointly predict action labels and corresponding 3D poses. For broad applicability, our approach only requires readily available observations in 2D. Previous work has focused on forecasting actions and 3D poses separately. For future action forecasting from 2D observations, the goal is to forecast a sequence of actions most likely to happen next. However, action labels are only an abstract representation of the forecasted future, while 3D human poses provide a more concrete realization of future actions. On the other hand, 3D human pose forecasting aims to forecast a short-term future 3D pose sequence that plausibly continues the input. Our goal is to model long-term future behavior, so we instead forecast a series of characteristic 3D poses, each one representing a sub-action in a complete sequence. Available 3D human pose datasets focus on constrained settings without complex actions due to the high cost of 3D pose data collection. Thus, we propose to leverage complex and unconstrained action sequences from 2D data, combined with a database of valid 3D poses, allowing for forecasting in 3D. From 2D data, we extract 2D poses characterizing each sub-action, along with the annotated actions, while extracting valid 3D poses from multiple existing 3D pose datasets. Our approach does not require any correspondence between 2D and 3D poses. We take as input a sequence of 2D characteristic poses extracted from RGB image observations. These poses, along with the corresponding actions and used objects, are first encoded into a combined latent space. A decoder then produces the likely next action label and corresponding characteristic 3D pose. We supervise our model with 3 losses: a cross-entropy loss on the predicted action label, a 3D adversarial loss based on our database of valid 3D skeletons, and a 2D joint loss on the projected characteristic 3D pose prediction. We formulate our approach autoregressively to allow for sequence prediction. We evaluate the effect of our joint action and 3D pose forecasting in terms of 2D MP-JPE pose error and compare against state-of-the-art 3D pose forecasting approaches on both datasets. Our jointly forecasted poses not only improve over these baselines, but we also see that action prediction helps to inform the pose forecasting. Similarly, we see that pose forecasting benefits action accuracy, demonstrating the complementary nature of both tasks. Predicting poses alongside action labels helps to achieve more robust autoregressive action forecasting for longer sequences. Predicted 3D poses are visualized here along with fitted simple bodies from an angled view as well as their projection into 2D. Our method forecasts characteristic poses that more accurately follow the target in realizing the action label prediction for both datasets. Our method enables forecasting long-term human behavior by jointly modeling characteristic 3D poses and action labels. This results in more accurate forecasting than previous work performing each task separately. Thanks for watching.